Hello everyone, my name is Shambhavi. Hope you all are doing well. So we were discussing about the summary regarding all of these topics which we have studied. So we're discussing about the goodness of fit hypothesis test. Then we had taken out the summary of the test of independence, right? So now I'm moving towards to the next one, and that's the test of homogeneity. So this time I'm going to take out some new colors so that we are able to write out the things right here. Let's write it out. Next point, I am having here test of homogeneity. Test of homogeneity. Right, this is what we are going to discuss up right here. Okay, so let's discuss at the very first point that it is basically use the test use the test for homogeneity. Use the test for homogeneity. Use the test for homogeneity to decide if two populations with unknown distributions have the same distribution as each other. Okay, this is what the test of homogeneity is first of all used for. So use a test for homogeneity to decide if two populations with unknown distributions have the same distribution as each other. Okay, now let me just calm down here. What is the second point that we are having? So the second point is that the degrees here goes, yeah. So the degrees of freedom are equal to number of columns minus 1. Right, this is what the degrees of freedom are. So the degrees of freedom are equal to the number of columns minus 1. Moving towards the third point, we have the test statistic which we are having is, let me just quickly get out some space. So yeah, it is sigma I into j O minus E whole square divided by E. Right, this is the test statistic which we are having. So the test statistics is this. What are the O, E and Ij? So yeah, I hope you are very much clear again with that. O is the observed value, E is the expected value, I, we have the number of rows, and J is the number of columns. So I'm not going to write that out again. Okay, right here. Let's move toward the fourth point. So yeah, this test is as well. So that I would write out that the test is right. Tailed. Right? Yeah, this is about this particular test as well. That this test is right tailed. Then we have number 5. So for the fifth point, if we have that if the null hypothesis is true. Again, let me just come down that if the null hypothesis is true, then the expected number that's capital E. Okay, then the expected number that is the capital E. It is basically equal to row total multiplied by column total and divided by total surveyed. So here goes the total and here goes the surveyed. Okay, so yeah, this is regarding this particular, that if the null hypothesis is true, then the expected number, that is E, which is equal to the row total, column total and the total surveyed. Okay, great. Now let me just come down here. So yeah, this was about the test of homogeneity. So in that case, basically we have one another thing, that the expected value for each cell needs to be at least 5. That's a minimum, right? That's a minimum, that it needs to be at least 5 in order to use out the goodness of fit, right? So in this is basically about that particular one. Now next I'm having the test of single variance. Let's see about the test of single variance. Next year I am having, I will just write out of single variance. Test of single variance right here. Let's start it out. So basically we use the test to determine, variation. So use the test to determine out the variation. So this is where we use out this particular test. So we use out this test to determine out the variation, right? I hope I am clear with this particular thing. Next, basically, what are the degrees of freedom? So the degrees of freedom, are the number of, the degrees of freedom are the number of samples minus 1. So degrees of freedom which we are having, that are the number of samples subtracted by 1. Now next we are having that the test statistic. So the test statistic is basically, now what's the test statistic that we are having? Let me just go down and write it out. So the test statistic is n minus 1 multiplication s squared. Right, is a test statistic which we are having. It is n minus 1 multiplication s squared divided by sigma squared. Okay. What are these values? So where n is equal to the total number of data, it is the total number of okay, let me write it out. Data, it is the total number of data. Fine. So where n is the total number of data. Next, what about next? So it is the s squared is equal to, that's the sample variance. So s is basically the sample variance. Okay. What about the sigma squared? So that sigma squared is the population. So it's the population variance. So variance. Right, so where basically these are the terms that we are having. N is the total number of data, S squared is the sample variance, and sigma squared is the population variance, right? Coming down. Now, okay, we have 4 point, right? So now 4th point that we are having, so it can be that the test, in this particular we do not have a condition that the test is only right skewed. So test may be left, okay, one second, maybe left, right, or, so the test which we are having here, it might be left, right, or it could be as well two tailed. So for the above 3 we had seen that the test can only be right tailed, right? So now it's not that case right here in this particular test of single variance. So here it goes that the test could be right, left, or two tailed as well, right? Now let me just go above once. Okay, one second. Right, it's summary of the formulas. So yeah, these were the formulas that we have seen. So for the test statistics, we have goodness of fit hypothesis test. So for that, the test statistics is sigma k, in brackets we have 0 minus e whole square divided by e, right? Next, we are having that the test for the independence. So in that case, the formula for the test statistic is sigma I multiply j, in bracket we have 0 minus e whole square divided by e, right? Now next we are having out here regarding the null hypothesis. So null hypothesis is true, then basically the expected number is e is equal to row total into column total divided by total surveyed. Then we are having the test of homogeneity. So in that case, you are having the test statistic, that is sigma I multiplied by j. In the brackets, we have 0 minus e whole square divided by e. And then if I move towards the, one second, if I move towards the null hypothesis, in that case, if it is true, then the expected number which we could have is E is equal to row total into column total, okay, divided by the total surveyed, fine. Test of single variance, into that we are having test statistic as n minus 1 into s square divided by sigma square. And in that case, the test might be right, left or two-tailed, doesn't matter at all completely, right? So hope I am very much clear with these particular comparisons, these particular formulas regarding all the four topics which we have studied under the chi-square distribution. Right? Hope I made up these things very much clear to you. So now I will be meeting with you in the next video. So this is all for this video. Till then, thank you and take care.